All right, today we're going to take a journey into the world's deserts, but we're going way beyond the typical images of endless sand dunes. We're going to really get into what truly defines these incredible and surprisingly sensitive ecosystems.
So let me ask you, when I say the word desert, what's the first thing that pops into your head? Is it something like this? Blistering sun, rolling dunes, maybe a camel trekking across the horizon? And yeah, that's definitely part of the story, but it is nowhere near the whole picture. The reality of what makes a desert is way more fascinating and diverse than you probably think.
So here's our game plan. First, we'll nail down what a desert actually is. Then we'll dive into the two major types. You got it, hot and cold. After that, we'll look at the absolutely ingenious ways life has found to survive in these extremes, see how those iconic landscapes get carved out, and finally, we'll tackle the really important topic of desertification. Okay, first question. What's the one thing, the single characteristic that unites every single desert on this planet, from the scorching Sahara to the frozen plains of Antarctica? It's not the temperature, not at all. It's the dryness, the aridity. The official scientific definition is super clear about this. A desert is an area defined by its extreme lack of moisture. We're talking about places with incredibly low rainfall, usually less than 25 centimeters or about 10 inches a year. That right there is the key. Forget the heat, it's all about the water. And you know, these arid lands aren't just tiny little spots on the map. Deserts cover roughly 1/7 of our planet's entire land surface. Think about that. That is a huge chunk of the globe, which makes them a massively important ecosystem to understand. So now that we've established that aridity is the name of the game, let's explore its two main flavors. Because while all deserts are dry, they are definitely not all hot. It's time to look at the huge differences between hot and cold deserts.
And what's really fascinating is how their location basically decides what kind of desert they become. On one hand, you have hot deserts. They're usually found on the western coasts of continents in a pretty specific band of latitude, where high-pressure systems and trade winds literally push moisture away from the land. On the other hand, you've got cold deserts. These form deep inside continents, just too far for ocean moisture to reach. Or they're tucked behind massive mountain ranges in what's called a rain shadow, where the mountains block all the rain-filled clouds.
When you think of a classic hot desert, the Sahara is probably what comes to mind. It's the biggest one in the world. But this group also includes some amazing places, like the Atacama in South America, which is literally the driest nonpolar place on Earth, plus the Thar in India and the Kalahari in southern Africa. Now for cold deserts. Picture these vast inland regions like the Gobi in Central Asia. Or think about super high altitude places like Ladakh and the Spiti Valley in India. Here, freezing winters are the norm and temperatures can drop to a mind-boggling -50 degrees Celsius. Still incredibly dry, but a completely different world from the heat of the Sahara. So with these crazy extremes, either intense heat or intense cold, and always a severe lack of water, you have to wonder, how on earth does anything manage to live here? Well, the truth is, life doesn't just scrape by in the desert. It has evolved some truly incredible, highly specialized strategies to actually thrive. Let's start with the plants. They have a really cool scientific name, a xerophyte. Basically, this is any plant species that has developed special features to cope in an environment where water is the most precious and most limited resource you can find. And their survival tactics are genius. Many of them have ridiculously long roots that tunnel deep underground searching for groundwater. Their leaves are often super waxy or even shrunk down into needles, which drastically reduces water loss. And then you have succulents, like cacti, whose thick, fleshy stems basically act like personal water barrels. You'll also notice they tend to grow far apart from each other. It's nature's way of social distancing to make sure no one is competing for the same scarce resources. The animals are just as brilliant. A lot of them are nocturnal, which is a great strategy. Just sleep through the hottest part of the day and come out in the cool of the night. On the inside, their bodies are masters of conservation, often producing highly concentrated urine to avoid losing precious water. Physical features like long legs do more than just help them run. They keep their bodies up and away from the scorching hot ground. And of course, a classic move, burrowing underground to find a cool escape from the brutal temperatures up on the surface. Some animals take survival to a whole other level with something called aestivation. The easiest way to think about it is like hibernation, but instead of doing it to survive the cold, they do it to survive extreme heat and drought. They just enter this dormant state, slow their metabolism way down, and basically wait out the absolute worst, driest parts of the year until conditions get better. Okay, let's switch gears a little. We've talked about the life in the desert, but what about the land itself? Those iconic shapes and features you see in desert landscapes. They're sculpted by two incredibly powerful and sometimes contradictory forces: wind and water. And here is a perfect example of how that works over geologic time. You start with a mesa, which is just Spanish for table, this big, flat-topped landmass with a really hard, resistant layer of rock on top. Then, over thousands and millions of years, wind and the occasional flash flood chip away at the softer rock layers on the sides. This process just keeps going, shrinking it down until all that's left is a smaller, lonely, flat-topped hill called a butte. And this constant sculpting creates this amazing variety of landforms. You get these cool mushroom-shaped rocks called rock pedestals carved out by sandblasting winds. Of course, you get the classic sand dunes, which the wind can shape into perfect crescents. But don't forget about water. It carves out dry riverbeds, called wadis, that can turn into violent rivers during a sudden storm. And it forms temporary lakes in low spots, which then evaporate and leave behind these vast, shimmering salt flats. All right, for our final section, we need to talk about something really critical, an issue that connects these natural desert systems directly to all of us. We're going to talk about the process of desertification.
Now, it is absolutely vital that we get this definition right. Desertification is not the natural, slow expansion of existing deserts. It is land degradation. It's the process where land that was once productive, even if it was dry, loses its fertility and becomes useless. And it's driven by a mix of climate shifts and, this is the key part, human activities.
So, what are these human activities? Well, this chart lays it out pretty clearly. The single biggest cause worldwide is overgrazing. That's when too many animals eat up all the vegetation, leaving the soil bare and vulnerable. After that, you've got deforestation, farming practices that just can't be sustained, and the expansion of cities and mining operations.
And if you want to understand just how big this problem is, look at this number. In India alone, almost 30% of the entire country's land area is currently dealing with some form of degradation. This isn't some far-off, abstract threat. This is a massive challenge that's happening right now.
I think this quote just perfectly sums up how a healthy desert ecosystem works. It's like a high-interest savings account, but for water. Every single drop of rain is a deposit that the system carefully absorbs, stores, and then spends with extreme efficiency. Desertification, that's what happens when we completely bankrupt that account.
And all of this leaves us with one last, really critical question to think about. As our planet's climate continues to change, and as we continue to alter the way we use the land, we have to ask ourselves, are our actions today accidentally creating the vast, barren deserts of tomorrow?